A ver. Ah, no, ahora sí, ahora sí. Sí. Creo que es. Creo que de pronto, ¿será que es? Sí, ahora sí. Ahora sí se está oyendo. Pero, pero no, yo no quiero que se
Hola,
oiga
hola,
ahí.
hola, hola.
No, yo no quiero que se oiga ahí, solamente acá. Así está.
Solamente.
Sí, pero si está, está bien. Ok. Bueno, muchas gracias. Ok, hasta luego. Okay. So I just handed out the new syllabus. Did everybody get one? Okay. And we're going to start. That's not full. Are there any more left yet? Is it needed? No, it's not. Okay. So, and I'm going to start taking attendance today. So, we're going to start talking about proofs today. What are you doing in the lab? Proofs? You're already starting proving things or no? Oh, yes, but only truth tables? Okay, so now we're going to start talking about the inference rules. The most important inference rule we're going to use is replacing equals by equals for equals. And it should all be here. Let me know if you can actually see this when you log into Sipua. Okay, so now you have something that is very important. If you see our midterms will take place during your lab hours. I'll see if we could, and you'll have to do something with your lab hours because we can't go on missing class. So then I'll take and then the midterms will be maybe not in the same room. If I can get another room that's better, I'll let you know. But they will be on September 22nd and October 25th. They're here. On Wednesdays. You have your lab on Wednesdays, right? I haven't uploaded yet. So you have to. I'll upload it this afternoon. So now we're here. Material de la sección, and we're in logic as a tool. Have you read the hat problem? Logic, then homework for next class. Read the hat problem and we'll solve it. You find it here. Content. Material de la sección. That's everything that I've uploaded is there. See here. So then, wow, I didn't see that. You didn't know that existed. Okay. Here something about regarding translating to propositional logic is here, how to achieve proficiency in this course. Practice, practice, practice. Here, I give you something that you should work on. Apart from your labs, apart from everything, you should work on this for next semester, for the first midterm. I assume you will pass this course, so not next semester. Okay. So then the idea is, remember that we talked about that when you have a formal system, you have things called axioms and things that you have to prove that are theorems. So here I tell you Table one, the first two rules are axioms, and the first exercise is to prove the negation of false here. Table two has the equivalence theorems for or and. The negation of or is often called the excluded middle. The negation of and is called contradiction. All theorems regarding or, the ones on the left, except negated absorption, except this one, are axioms. So then I want you to prove all of these, all of the other ones. So I won't grade them, I won't do any, but it's only so you can practice. We'll solve a couple of them right now. So then, last thing we saw in class, it was 2 weeks ago, was translating from propositional logic. I gave you a few examples, mostly about crimes, and we wanted to know who was the guilty party. And then we'll go on to solve some other problems here. Okay. Under content, material de la sección, I think. And look, this is content, material de la sección, logic as a tool. And I want you to look at these problems. We'll talk about these problems. 6 and 7 are interesting. If we have time, we'll work on them later. But I want to go on to, oh, and I have a gift for you, but of course I didn't pay for it. The department paid for it, so it was probably paid by your tuition, not like politicians who go to, oh, this is a gift, and you wrote, it's my gift from me to you. No, it's not the politician, it's your taxes. So take one. You can use this in the exam. This is your cheat sheet. Pardon me? Silence, please. There's a question. You can modify and you could add things to it. But you have to use this one, but you can add things in the back, things. I am taping the class. I'm recording the class, so then they're hearing everything that you're saying. I'm recording the class. The class is being recorded, okay? Okay. Proving theorems in the propositional calculus. So, use a cheat sheet. Unless otherwise stated, all of the rules are axioms. However, to practice proving theorems, you may assume that only a subset of these axioms and you may assume that only a subset of these are axioms and prove the rest in a particular order. I give you the order in the and that's practice. You find it in the same part of CICUA Plus. How can we determine if an axiom is in fact valid? Well, using a truth table. This is the main inference rule that we're going to use. It's Leibniz, but it means if you know that x is equal to y and x occurs in an expression, you can substitute y for x in that expression. And if this expression is true, then the expression in which you substituted y for x is also true. Replace equals by equals. That's what it says there. Proving equivalences. If you want to prove that P is equivalent to Q, start with P, apply equivalence axioms or theorems to get to Q. Or start with Q and apply equivalence axioms or theorems to get to P. Start with P equals Q and apply equivalence axioms or theorems to get to true, or to a known theorem or axiom. Or prove P implies Q and Q implies P. This is perhaps the most important slide that you will see throughout the semester. These are the ways you can prove that P equals Q. Okay? You can take a picture of it and say, remember this. Okay? Now let's say I want to prove I have the following axioms. Double negation. Double negation is that if you can shut the door. I was going to shut it right now, but since you just came in, okay. So I know that not P is equal to P, and I know that false is equal to not true. If I assume that those two are axioms, I want to prove that not false is equal to true. So then I start with not false. If you look at this table here, the only theorem I can apply is false is equal to not true. I don't have a double negation anywhere. So the only thing I could do is replace false, replace not true for false. So by the definition of false, then this is not true. Have to make sure that you don't forget that you had this negation here. So then the next line would be not true. I replace not true for false. What would you do there? Double negation, and you would get true. Very easy, right? So all of the theorems that you prove when you want to prove that P is equal to true will be something like this. Maybe more complicated, but it's just this, nothing else. The more than. If you have your cheat sheet there, I'm going to prove De Morgan of and using all of the or axioms and double negation. If we start with De Morgan there and you only have the people who just walked in, you have there are things here, the syllabus and the cheat sheet, you have it there. So then you only have the things that are on the left-hand side of this column. You have them there. So if you see there's nothing, there are no more. Oh, I have one more here. Who just walked in? And you have this now. This the axioms? Oh no, those are the axioms. The syllabus here. Well, there should be also 30 syllabus. They should be wandering around here somewhere. Here. Here's your syllabus. You have everything? Does everybody have two things? What do you mean? Both? If you see this, what you want to prove that not P and Q is equal to not P or not Q. However, there's nothing, if you look at the axioms, we don't have anything that can help me replace P and Q for something else. I have something like not P and not Q, but nothing else. So then we have to start on the left-hand side. I'm going to prove that the right-hand side is equal to the left-hand side. From right to left. Why? Because we don't know how to rewrite anything of the form not P and Q, nor of the form P and Q. Now, the only thing I can do with that is I do know how to negate an OR, but I don't see a negation there. Then what I do there is I apply double negation. And I get this. Did you do this in the lab? No. So then, now if you look at the left-hand side, you do have De Morgan for, something about De Morgan. Since it's in English, then there's no way you can make a mistake. De Morgan is a last name with De Morgan. So if you're going to apply the rule, you have to use De Morgan's rule. And if you're writing it in Spanish, you can't say La Ley de Morgan. No, it's La Ley de Morgan, because De Morgan is the last name. It's not Morgan, but De Morgan. Okay, so now, what rule would you apply there? Look at your rules there. Do you know anything that's, something important here is that you see these are as placeholders. Is not something, let's see if I can, the rules are placeholders. It means it's not P or Q. It's not something or another thing. So then I can apply De Morgan there. So what would happen if I apply De Morgan there? What would look at De Morgan in your, which is this rule. De Morgan says not P or Q is equal to not P and not Q, In this case, not P is my new P and not Q is the new Q. So then you would get De Morgan, not P and not Q. So what would you do here? Double negative, double negation twice, and you get not P and Q. Magic, right? Yes? No, I use De Morgan of OR, and no, there's no other way to prove it. Not with what we have now. You can always prove it with you could prove it another way. You could prove it by cases. You assume P is true and assume P is false and prove it, and then you could prove it that way. Let's prove it that way. Here we have not P and not Q, like one underline and two underlines, then it means that. Okay, let's see if we can write this like this. I'm gonna do it, I'm gonna better on the board. If I want to prove something by cases, you have to take a proposition and you prove that if that proposition is true, then it makes this true, and if that proposition is false, it makes it false. proving by cases is like proving it by truth tables, but not exactly, because I'm only using one variable, not two. So if I assume then I would have to prove that not true and not true and q is equal to not true or not q. There is a problem here. I have to, for this, I would have to prove that true and q is equal to q. And that would be identity of and I believe that to prove identity of I have to use an order. So I don't think I can use it. The thing is, you have to keep an order. If I would do it here, then I would kind of be cheating because it would be not, this would be q is equal to false or not q. And false or not q by the identity of or is not q. But the problem is that I'm using identity of and. And to prove identity of and, I have to use the Morgan. Then it would be wrong. You can't do that. You can't go, you have to make sure that you keep a straight line in your deductions. And then the other one would be with false. Suppose P is true, false. Domination of and, that would be false. And that would be not false, would be not false by negation of false is true. Now true or not q is true by domination of or. And this is true by negation of false. The problem is that I am using domination of and identity of and for that I have to use to prove those two I have to use the Morgan. So then it's wrong.